new nice picture this time. So we are almost ready to start. We just having some last instruction on how to run the laptop. Okay, so this is the MPLS working group meeting in Montreal. We had 2 slots scheduled when we started, but we actually found out that we could make it 2 hours. So from having a lot of room to actually have a lot of discussion, we actually are going to pretty squeezed agenda. But doing the second session for only 15 minutes didn't make sense. So one session, the next session is cancelled. Um, so we have a number of changes since last time. First of all, I want to actually join me in welcoming George Swallow back to the MPLS working group. The last time you were here was London, wasn't it? Yeah. We have one chair, Nick. He's back in Germany, vacation. I didn't know that that was allowed, but he claimed it is. We have a new chair, Tarek Saad. Please welcome Tarek. And since Tarek left his post as secretary, we also have a new secretary, Mac Chan. With that, I think we're ready to start. You have the note well on the screen. I say, as Chris said, morning meeting, I'm not going to read through all this, but it's important that you do. So please read the note well and understand what it means. Basically, it says, whatever you do here is contributing to IETF. Okay, the next slide. So the administrative things around here, we have audio streaming. So when you talk to the meeting, you stand in front of the microphone and go pretty close because they are set rather low. If you are presenting, there is a pink cross over here. You should stand on that, or at least close to it. And when you start speaking, state your name. Other than that, we have, I don't think we have any Meet Echo presentations, so that should be, but the Meet Echo is, the Etherpad is up and running, so if you want to add anything to it, you can do that as the meeting going on. You find the online agenda and slides at that URL. Next slide, please. So agenda bashing, this is the draft we intend to, this is the status report and the draft we intend to discuss. I think that the 3-minute slot at the end is moved out, and Tarek will discuss the Yang model drafts during the status report. Any comments? Okay, let's go on. There are blue sheets circulating. Fill them in and return them not to the shares, but to Mac. Over here. Next slide, please. So we have 2 erratas that we've been fixing this time. Both of them are fairly uncomplicated. The first one was that we used a 0 instead of a O, or if it was the other way around, I don't know. So this is verified, it's editorial, waiting for an update, and visible on the data tracker until that update happens. The next one, this is, sometimes you actually make work for yourself. So what happened here was that when the RC editor published the draft, they forgot to put the paragraph in. So we made an errata to put the paragraph back in, and that's now also listed as an editorial errata and also available or visible in the data tracker. Liaisons, we have had 2 outgoing and no incoming. That's actually the opposite to what it usually is. The ones are, the 2 liaisons are fairly easy. The one is a Together with other working groups, we actually responded on a liaison from IETF study group 15 on a work plan for OT&T standardization work. And the other one was also a question from study group 15 on a clarification on MPLS shared ring protection. Fairly straightforward. Okay, next. Document status. There had been a couple of meetings where we didn't have any new drafts. This time we suddenly have 3 drafts. Oh, sorry, RFCs, where we haven't had any new RFCs. This time we had 3 new RFCs. Thank you everyone that has been involved in authoring, reviewing, pushing on these documents so they actually got published. We have documents in the RFC editors queue. The first one was blocked because of a misref. The misref is gone. It's a rather big cluster that the RFC editors are working through just now, and they say that somewhere before Singapore, all those documents will go into Author 48. So when that happens, be prepared and actually respond quickly. We have documents with the ISG. They are progressing rather well. I don't think there is any real hiccups, though we are waiting for a revised ID for the egress protection framework. I haven't seen that yet, but it should be progressing. We have one new working group document, and that's the special purpose labels terminology. Short draft should be fairly easy. What the author said was that if we don't have any further comments, then we will request working group last call prior to Singapore. Actually, all of the documents we have in the working group part of the data tracker has been updated. So we are doing something to our DAOs, even though I kind of push hard on some of the authors. We have 2 recently expired drafts. Both of them are on the agenda, and that part of the agenda we will swap. I will swap out myself and swap Stuart in to explain what the issue is. Next thing. We have new individual drafts. All of them are on the agenda. And then we have updated individual drafts. I can't find any surprises here. There is one error though, because I've been working this afternoon. Draft Shang MPLS RMR multicast is no longer an individual draft. It's a working group draft. I accepted it this afternoon. And then we have an issue that was brought in. I have waited a bit to see what responses we got, but there is a mismatch between 3036, that 3036 was widely implemented, and 5036, and some implementations go through as 5036 and some at 3036, and that's a label format. And if 3036 is not explicit where the generic label should be put in that field, so it's we have assumed that it is on the least significant bits, but we will actually start a poll to some of the key implementers and ask what we have done and see if we have everyone doing the same thing. And once we actually understand the situation out there, we will actually write some text around around what should happen. Some of the reports on this is actually reports from at least ultimately from the authors. So we picked up a little bit here and there, actually reminding working group document author that you're actually supposed to give us a short update. We send you a mail before every meeting, but you need to respond to that and tell us what the situation is. On this page, the second draft is also wrong. It's actually not waiting for the Shepherd write-up review. It's actually, I have that. I have sent a request for publication for this draft today, so it should probably be somewhere else in the list. This actually affects the RMR extension, LDP or RMR extension, and it should also affect drafts in spring and geese, I think. They have RMR drafts also, so they should be possible to progress now. Okay. Go back. The first one, BAT directed. We tried to set up a meeting discussing this draft among authors and people that have been contributing to discussion on the list. One of the key people, Carlos, is not here, so we are moving the discussion to the working group mailing list. Okay, next. The MLDP MIB is a long-term draft. It's been there for a long time. We are actually just waiting for the MIB doctor, the final word to close the working group last call, and then go ahead and request publication. We have closed the working group last call for the summary, FRR, and RCPE. Again, on the special purpose latest terminology draft, we think it's ready for working group last call, but we will wait in a couple of weeks for comments. So if you have ideas and comments, please send them in. Egress protection framework has one discuss left, and I talked to Jimin today, and he will kind of fix that. The RSC 8287 length clarification is, I think it's pretty big. And the RSVP-FRR, we have comments that we need to address. SR over IP, I think this is, the text here was correct, so probably when we wrote it, but just now it's actually in the RSC editor's queue. So we need to change that. And then you have Yang models.
So, hello. So we wanted to give a quick update on the modeling that's happening in MPLS working group. We have a couple of drafts. To begin with, LDP modeling, MLDP and LDP for unicast and multicast. The first one, there is a working group last call request coming in from authors, and we will initiate this working group last call. For the second one, it has undergone a Yang doctor review cycle, and they received comments. The authors should be addressing the comments now and circle back to us. There are two other drafts for modeling in Yang as well, one for MPLS base. Both are in the Yang doctor's review. One, we got some feedback today, and the authors will be addressing the comments from the Yang doctors, and we will proceed for asking working group last call once we have all the comments addressed. Yeah.
So on the MLDP Yang, actually you will do the working group last call because I'm a co-author of that draft.
Oh, sure, definitely, yeah.
Oh.
Sleeping Beauty, back to you.
Sleeping Beauties, I think this is the third meeting we have this list. I actually put it on the MPLS wiki. You can find it through that URL. Those are drafts that was sent to the working group, but never progressed. And it's fairly unclear for most of them if people want to progress them or not. So I ask you to look at the list, see if you have anything there. If you have, fill in the information and tell us what your plans are. If it's just you won't progress it, it's fine. But we won't have a way of actually closing it down.
So we have Shraddha.
Where do I point it here? Where do I point it here?
No,
Here. Good evening. My name is Shraddha. We're going to talk about the EP OAM FEX, presenting on behalf of my co-authors. So on the agenda, we have background and problem statement. And this was presented in Bangkok, and we have updates from previous version and next steps. So that's the background. So we have EPE, SID, the peer node SID, peer set SID, and add SID that are getting advertised from, let's say, ASBR1 to the controller. And then this EPE SID is getting used in building a end-to-end SR path across multiple ASs, or it's getting used as a bottom label for a SR path up to the ASBR2. So what we want to do, so in this example, let's say there's a switch between ASBR1 and ASBR2, and the link shown here is broken. So in this case, we would want to do an MPLS ping and trace route and be able to detect the broken link. And the way to do it is the controller that sets up the LSP knows what the EP meaning of the EP SID is, whether it's a node SID and what are the associated links, whether it's a peer set SID and what are the associated links. So the controller includes that information, and the head end can do MPLS ping and trace route with those FECs. And then the FEC validation will happen on ASBR1. So there are three kinds of information that we need to validate. First thing is the control information that BGPLS has advertised an EPE SID, and it says certain information, and that information has to get validated when the packet comes in, the OAM packet comes in. That information has to match with what has been advertised. The second thing is the forwarding state has to match. So ASBR1 says it is sending traffic on, let's say, one link, the top link between ASBR1 and 2. And then when the packet really arrives on ASBR2, it needs to validate whether the incoming interface is matching with what ASBR1 said. So the way this gets advertised from ASBR1 is downstream detailed mapping TLV. This is from RFC 8029, and there is no change from that. So what we are doing here is we are just defining the FECs for the EPE SIDs for peer node SID, set SID, and adjacency SID. So updates from last revision. So the last revision had peer node SID with a single set of local and remote interfaces. So we changed the definition to include multiple sets of local and remote interfaces. That's because the peer node SID could have been advertised for a multi-hop eBGP session, and there may be multiple underlying links. So both the links, all the multiple links have to be included as part of the FEC definition. So the FEC definition has been updated for this. And there was a comment in from last presentation to optimize the peer set SID that has been incorporated. And the security consideration section has been updated. So that's the definition for the peer node SID. So we have the local AS number, remote AS number, local BGP router ID, and remote BGP router ID. We also have the number of interface pairs, pairs of local and multiple pairs of local and remote interface addresses. And there is an address family bit to indicate whether it's V4 or V6. So peer set SID, so there is local and AS number and router ID, and there are multiple sets of this remote node information, and along with there are so from based on, because the peer set SID can correspond to multiple node SIDs, peer node SIDs. So the changes that were done for peer node SID have also been incorporated in the set SID, where there are multiple number of interface pairs along with the address family. So there is another draft which is very similar approach. There are some minor differences in the FEC definition, and so we are talking to the authors. So beyond saying, hi, we have the same draft, we haven't made much progress, so we thought whatever update we have, we could present it this time. And we probably will talk to them tomorrow and then see how we can progress. And one more thing before I take questions. I wasn't too sure this is supposed to go in MPLS or Spring. I think I forgot what the decision was.
This one goes to MPLS so far.
Okay.
You need to use the mic. Not because I can't hear you, but because everyone else can.
Yeah, you're correct. Bruno de Crane-Orange, Spring co-chair. So yes, indeed, there is another draft which is similar. Last time it was presented in Spring. There was kind of an agreement to merge. So this probably needs to be sorted out before. Regarding Spring or MPLS, if you want to have it in, well, the definition of the FEC would be good to be discussed in Spring, because this is where it is defined and discussed. Now, if you want to do the code point in MPLS working group, I'm fine with doing the draft in MPLS working group.
This is again the same situation. We have a lot of drafts. We need to progress in somewhere, but you need to make sure that the other working group actually are aware of and part of the discussion. So, okay.
But if you want the draft to be in MPLS working group because there is a conpoint, it's okay for me. But the definition of the FAQ really needs to be discussed in spring because it cannot really be reviewed in MPLS.
So every update I post to both the working groups, it should be fine. Yeah.
Yeah, but one working group is, so here is how I see it. One working group is progressing. We make reports to the meeting in that working group, but discussions on technical issues goes to both working groups.
Yes, that's my point.
And if necessary, you make presentations in both working groups because it could be.
Yes. But my point is to have a reminder that for everything which is about definition of the FAQ, we need to discuss the change in spring because it's easy to say today, but maybe in 1 year from here we will have all forgot. But it's up to the watchers.
Thank you.
Sam Aldrin from Google. If you go to the picture, I have one question. So here, let's take if the path between switch and the SBR2 is broken, the packet is processed on the switch, correct? How does it get back to the source?
So the switch is not visible, right? It's a layer 3 connection between from ASBR1 to ASBR2, and we have advertised a SID which says it's sending traffic on those two links. So let's say that one is broken. So on ASBR1, when the packet comes in, it looks at the forwarding plane. It has two links. So in the downstream mapping, it says I have two links, and then the ECMP tracing happens in case of trace route.
No, I'm talking about the echo response.
Okay.
How does it get back to the source?
Yeah, so I think we have another draft.
So my question is,
so
are you mandating the next draft to be part of this solution?
So this draft is basically talks only about the FAQ definition,
right.
But if you see end-to-end solution, you would need some way of sending the packet back. So I think we have a next presentation that talks about how that can be done.
Okay, I'll hold the question.
Sure.
Hi, this is Zafar Francisco. Can you go back to that FAQ definition? So I have two comments. Comment number one is that when you have pair set, you cannot.
This is pair node.
No, the next one.
The next one.
You can go to the next one. Yeah, that's fine. So in the pair set, you cannot identify the interface on which the FAQ needs to go. So we are listing all of them. And in the pair node as well, there's a lot of information. From a user interface, and this is a problem with the FAQ, because the FAQ definition started from MPLS when we had like LDP and RSCPTE. Now with segment routing, every time we're defining a new SID, we're finding need for a new FAQ, which is a problem, because if you look at it, even the information needed here, how much parameter user are going to input is way too much. So I'm concerned about the complexity that is involved in a solution, and we need to step back from defining a FAQ for every SIG type to define a FAQ that can cover all SIG type. Segment routing is all about simplification. So this is my major comment. I have a follow-up presentation to that effect, but that's my major comment on this stuff.
Yeah, so it's not necessary that the user has to input the local interface and remote interface and all of this, because this has to get advertised via BGPLS from the router to the controller. And then there is one entity which understands what this SID means, and that entity can somehow get that information, encoded in a FAQ. So it's all about, how you get the entire solution to work.
But I think the problem is that you rely on control plane.
I kind of lost the picture here, because I think I need it in text. Can you go back and write your question in an email, send it to the list, and you respond?
Yeah,
Sure.
that's fine.
Thank you.
Yeah, but I just one comment. you're relying on control plane to verify control plane. So that is the problem.
Greg Mixon, ZT. I'm looking at this capture and doesn't look like there is a typo. That you probably will have either 4 octets or for IPv6 you will have 16, not
Yeah.
6. Okay.
Oh, 16, yeah.
Yeah, okay. Then
Sorry.
okay, I
Yeah.
just
I'll
want to
go
double
fix it,
check
yeah.
that I'm reading it right.
Yeah, maybe it's wrong in the draft as well.
Yeah.
I'll go fix it.
What I would suggest you is that it's probably likely that local and remote address will be the same family. So somehow highlight it that it's must be one family. It cannot be local address
Yeah,
v4
sure.
and remote v6.
Yeah, sure.
Okay.
Yeah.
So make it more strict. And if we can go to the other side, I think that in answering Sam's question, you said that there is some trace route takes place. Is it trace route from ASBR or trace route from the head end?
It's trace route from the head end when there is an SR path constructed using those EP SIDs.
Okay, in my experience, trace route in ECMP is a black magic. So it will be very useful if you can describe how you guarantee that you explore all available paths. Because I understand
sure.
that's one of the
Greg,
key
we
technologies.
understand what you're after. We can need to cut it here. Okay. Next presentation.
Is this way to move?
2 minutes later.
Okay. Hi, good evening, everyone. I am Mukul from Juniper Networks, and I will be presenting InterOS OM for SR networks on behalf of all authors. So the agenda of my presentation will be, first I will talk about the problem statement and a few RFCs previous work which we have found, which is related to this problem. And we will discuss what is the issues with that and our proposal, how we are trying to solve it. And we have a working example to explain our proposal. So Inter-AS OM problem is a well-known problem. We have, I think it has been worked in the past. But here we are trying to, this problem which I'm trying to state is applicable more for the SR network. So we have two ASs, AS1 and AS2, and we have and both the sides we have SR path setup. There is a controller which gets the BGP LS feed from ASBR from both the AS, and that's how he knows the topology of both the AS, and it can push that information to the ingress R1 and also set up LSP across AS. So in this example, let's say we have, with the help of controller, there is a LSP setup from R1, R2, ASBR1, ASBR3, R3, and R4. Now, now this LSP is across AS, and if you try to do a OM mechanism across AS, then the router on the AS2 will not have the return path, and hence the problem is the ping and traceroute will not work across AS. So these are the two previous work which we have found. There might be some drafts, but at least these two RFCs, the first one, it talks about pings and traceroute from a PSM. And this is not related to inter-AS, but the problem with this draft is it tries to set up a return path from each node using GRE tunnels, which is not very scalable, and it is operationally extensive. The second draft, 7743, it talks about for the MPLS LSPs, inter-AS OM, and there they have defined a new TLV, eco relay, node relay address stack TLV, which essentially puts the IP address of the router which does the relay. But the problem with this is the packet for each hop has to go up to the control plane. So basically each hop, we are taking the packet up to the control plane, which is again not good. So the proposal which we are trying to do is for the SR network, we define a reverse path using a stack of SID labels. So we define a new stack TLV, reverse path label stack TLV, which is a set of labels, a stack of labels, which the ingress router can put when the echo request is generated. And how it knows is it could be via the controller, or it is pre-known at the head end, but that is not part of this RFC. But it is possible that the head end knows about the return path, and that it can be put into reverse path label stack TLV, and the echo request reaches up to the endpoint. This reverse path stack TLV will essentially contain a list of SIDs, which could be prefix SID, adjacency SID, binding SIDs, or EPE SIDs. And essentially when the router at the second AS, when he receives the echo request, while responding back, all it has to do is copy those labels from the echo request to construct the echo reply. So so this solves a problem that the packet does not go to control plane at each and every hop. So it's all data plane forwarding across AS. This is the packet format for the reverse path label stack TLV. Essentially, the key thing over here is the number of labels, which tells you it is order set of labels in the reverse path, starting from the receiving router, and then it is a set of labels. So this is a working example. We do have a small prototype for this thing, but if you take the same LSP which we had in the first slide, let's say we have set up LSP starting from R1 and ending at R4, the echo request will go with this set of SIDs, which have the terminologies. These are the node SID for R2, ASBR1, ASBR3, and node SID of PE4, R4, essentially, I think. And for this echo request, the reverse path will be the set of labels starting from R4 back to R1. So in this example, the reverse path TLV will contain this set of labels. Node SID for SR4, let's say if it has to come via the ASBR4, then EPE SID for ASBR4, between ASBR4 and 1, and then node SID for R1. So R1 will just essentially take these labels and put that while responding back to the echo request. So that's all. I think this is my last slide. The request is to adopt it as a MPLS working document. Thank you.
Greg Mirsky, ZT.
Wait. As a matter of fact, you have to actually send us a mail with that request to make it a working group document.
I think
For tracking purposes, we need it.
Okay. I think there was a mail, but we'll check. Okay.
Okay.
Yeah.
Again, Greg Mirsky, ZT. I would have to say that this is not novel idea. So Lowell mentioned their stalled discussion of BFD directed, and BFD directed used to have a portion of this proposal, but now it's a part of individual draft in Spring Working Group on draft Mirsky Spring BFD, which proposes to use explicit list of SIDs for controlling the return for BFD. So what you're proposing is already being proposed.
Okay.
So I appreciate your looking into this draft and welcome your comments.
So your
General, Mike.
My name is Shraddha. So your proposal, you also use MPLS ping and trace route to get the...
I think that is for VFD.
Okay, MPLS OSP ping is used to bootstrap BFD session, but part of the proposal is that it can communicate the list of SIDs to be used to direct BFD. But at the same time, it mentions that the same can be used to direct response for their Spring ping itself. So it's already there.
Okay, so we'll look into that. Yeah.
So I got the line off the Sapphire, and please be quick. We are a little bit over time.
Sure. Sam Aldrin from Google. I want to actually go back to the working scenario. I'm okay, but when things fail, right? Let's take in the topology diagram.
Okay. The first one.
If the ping request fails for whatever reason between ASBR1 and ASBR2 or 3, in that case ASBR3, right?
Right.
So what exactly the return path label stack it's going to use? Because you're populating with, in this case, whatever that SID, you're saying that this is what you're going to use, right?
Right.
But it means nothing on that intermediate node.
But that you are talking about the ping. So ping, so that use case will be for the trace route, not for the ping. If
No,
the ping
even the
fails,
ping
that means
packet.
it is there is some breakage in that link. We do not do ping does not try to find out where the problem is. That is trace route. And
The ping packet, when the LSP is broken,
right.
it is going to be handled on the device where it gets popped. Is it right?
So I think you should take this discussion offline
Okay.
because you don't agree about the scenario really.
No,
I
this
think
is
the
a
ping
fundamental
response,
architecture because
the node which is generating the ping, I don't, if it is broken, it is not expecting any response from the node at the intermediate node from where it might be broken.
okay, I think there is a fundamental
I think
difference.
I said
So
take it offline.
Sure.
I meant that.
Yeah, I just want to comment on Greg's comment. It's two different things. Is here the return label stack is used for O&M purpose, and I have no problem. But using for BFD is a problem because you have SBFD. So it's a completely different thing. I think it's confusing. Greg comment is very confusing here.
That's right. Thank you. Thank you.
Yeah. Okay. Hello everyone, I'm Feng Wuqing from China Mobile. Now I will present this draft instead of the authors because they have the travel problem. This draft defines the encapsulation for MPLS performance measurements with the alternate marking method. In order to realize this method requires 1 kilobit of data packet to measure packet loss. Also, it requires 1 more time-step bit of data packet to measure delay and rate of data traffic flow. Of course, this method requires flow identification of the measured data traffic flow. This slide talks about how to measure the packet loss and delay. One thing to be aware that the measured traffic flow need to be partitioned over time. For packet loss measurement, coloring the measured traffic flow and flip the packet color periodically. Each node report its contours of each block to the EMS or controller. For packet delay measurement, marking one packet within each block. Each node reports its time steps of processing each marked packet to the EMS or controller. Here is the format with of the flow-based PM encapsulation with the alternate marking method. one flow ID indicator label followed by one flow ID label, which includes flow ID, L bit, D bit, S bit, and so on. The flow ID used as the MPLS flow identification. It must be unique and allocated by the AMS or controller based on the method object instance, such as LSP or PW. There is a one-to-one mapping between flow ID and flow. Note that the flow ID indicator label may appear many times in a lab stack, which means that the flow ID may present, which means more than one flow ID may present in MPLS label stack. L bit is used for the coloring the flow and measure packet loss. D bit is used to measure the delay. When the node receives the packet with the D set to 1, he needs to report the reception type to the AMS or controller. S bit is the bottom of the stack indicator. Here are some key features of this method. The first one is in band OEM. Whether to tunnel or VPN is based on in-band measurement, which is more accurate. This method supports hop by hop measurement. The translate nodes can count or record based on flow ID. Whether to tunnel or VPN is used the unified method to measure the packet loss or delay. They use the flow ID indicator plus flow ID. Each node counts data packet and record time, then report to the AMS or controller by telemetry, which is very timely. The AMS or controller calculated packet loss, delay, and jitter variation in hop by hop or end-to-end mode. Now I will talk about how to encapsulate, lookup, or decapsulate the flow ID. Before any measurement starts, the AMS or controller need to provision the unique flow ID to the measured object instance that at each network element. In the ingress note, the ingress note insert the flow ID indicator label alongside with the flow ID label. At the same time, the ingress note set the L bit, D bit, and flow ID values. The translate note look up the flow ID label with the help of the flow ID indicator and transmit the collected information to the AMS or controller, which includes the counters or count of packet loss and time steps. The egress note pops the flow ID label with the alongside with the flow ID label into the to the MPLS LSP MPLS level stack. This draft there are 3 examples on different layout of the flow ID in the draft. The first one is when this method applied to the LSP in MPLS network. The flow ID for the flow ID indicator and the flow ID are under the SR label. When applied to the VPN in MPLS network, the flow ID indicator and flow ID are at the knees of the VPN label. When this method applied to both LSP and VPN in MPLS network, they need 2 different flow ID values. That is to say, flow ID applied to LSP and flow ID applied to VPN share the same value space. Okay, yeah. Next steps. As for more reviews and comments, revise this draft to resolve comments. and last ask for WT working group adoption. Okay, and comments?
Yeah.
Yeah.
Hi, Tarek from Juniper. I
Yeah.
read your draft and I sent you some comments on the meeting group. I'm not sure if you saw them, but basically two general comments. There is another way that the working group is working on is called synonymous flow labels that can achieve this marking.
Yeah.
I'm not sure if you've taken a look at it or if this approach you think is better than or gives an advantage. This approach will introduce two labels in your stack. The flow identifier label, the special label,
Yeah.
and then the flow ID. And that one doesn't need those. So I encourage you to take a look at that and see if it fits your need or not. Second comment, if you go back a couple of slides to where you have the encoding of the flow ID in the stack.
Sorry,
Yeah,
this
here.
one? Yeah.
Yeah. So basically, you're redefining the label and the encoding of a label with bits to mean different things. You're setting certain bits to be for measurement of loss and delay and other things. This is not usual that you encode certain bits in the label to mean certain things in the MPLS. I haven't seen that recently. So, well, it is part of the label stack, right?
Yeah.
Yeah.
Are you?
What I'm saying is that it's not a label, but it's part of the label stack that we have some discrepancies there that we need to resolve. We are late, so
Very quick
if you
comment
don't want to steal time from yourself,
from myself. Yeah, it's very quick comment. Rakesh from Cisco, have you looked at the IOM data fields? Because there could be one option of using IOM data field that allows you to do some of these things very.
So sorry, because this draft, I'm not the author of this draft. Maybe the author can independent.
So you're actually getting into a situation that, let's say, take it offline, meet after the meeting and actually discuss it and see if you can reach a common view and report to the list.
Yeah. Okay.
Okay.
Yeah.
Good afternoon, everyone. My name is Rakesh Gandhi, and I'm presenting the draft on IOAM for SRMPLS on behalf of all the authors and contributors. So the agenda is look at the requirements and scope, the procedures, and the next steps. So requirements is to transport the IOAM data fields with SRMPLS and CAP. So basically carrying the OAM information like timestamps by the data traffic. So the scope is using the data fields already defined by IPPM working group and end-to-end IOAM. We can look at the hop by hop as well in future if there is interest. So the NCAP looks like basically there is an IOAM indicator label and the IOM data fields that's defined in the draft from IPPM. So the NCAP node will insert the indicator label and the data field, and the DCAP node will take a copy of the data packet and forward the data packet. So the copy will be processed for the OAM, and it will also remove the NCAP. So there are a few methods that can be used for indicator label allocation, and we can use some feedback from the working group. So one approach could be that we use an extended special purpose label. So we allocate a label, maybe say 18, 19. There can be a network programming label that's allocated by a controller for this, and controller would go and provision all the NCAP and DCAP nodes. Or there is signaling where the cap node would signal it to the NCAP nodes. There is some implication on hashing.
If you have the second method here, does it mean that you can't have a network without a centralized controller? You need to have the controller in the network.
Either a controller provisions it or it's done by a CLI, for example. Yeah. So there is some implication on hashing because we are changing the MPLS header and there are some transit nodes that may use the MPLS header, all the labels for hashing. So now it may include IOM label. There are some nodes that may look for the well-known protocol type for IP hashing. So now there is some implication there as well. So there is definitely some more work and discussion required on the hashing part for this draft. So next. So next steps, as mentioned, there is some work required for ECMP hashing. We can definitely get good feedback from the working group. Some feedback on the hop by hop IOM as well. We welcome your comments and suggestions, and we are seeking working group adoption for this draft. Thanks.
Yes, one question, Rakesh. Tariq from Juniper as an individual contributor. If you go 3 slides back, one more. Yeah. So in the second approach, is it global label in the whole network?
Yeah.
Or just between the ingress and egress that's significant, this label?
Yeah, it will be easier to just have one label, let's say label, 500 or so. That means this purpose, and everybody understands what 500 means in the network.
It becomes a special purpose label.
Then it becomes a special purpose label.
Greg Miskaziti. There might be a problem that characteristic to MPLS and SR-MPLS is that you don't know where this came from. So how you differentiate the source, how you attribute, especially if you use the same label advertised by the egress for all the possible encapsulators. How do you know where the source of this and where the statistics to attribute to?
So it knows today, right?
With the sake of, let's take it to the list, but just a question.
Okay.
Thank you.
Thanks.
Okay, I'm presenting on behalf of my colleague, and I'm one of the co-authors of this draft. So, path segment SID has been adopted recently as a working group document, and this draft raises and will start a discussion and propose solution for using the path segment as interworking between SR-MPLS and MPLS domains. So the path segment is defined in this path segment draft, which is a working group draft for the Spring Working Group, and it identifies the path and allocated by their egress. Not only identify this for the purpose of OEM and performance monitoring, but also it may be used for correlating for interdomain and in bidirectional interdomain path correlation. So in one of the possible scenarios that we have multiple domains from their access to the core network and need to do end-to-end OEM and with their incremental deployment, for example, of SR-MPLS, we might have a combination of SRMPLS domains and IPMPLS domains. And then we're considering the scenarios, how this can be organized, whether we're considering two models. One is a stitching, and then it's encapsulation, so basically their tunnel through the domain. In case of stitching, then we have for each domain path SID, which we refer as an IPath, and then they can be by the border node correlated from one domain to another domain, and then thus providing end-to-end correlation. For the nesting or tunneling model, there exists end-to-end path, and then each node might have an what's called as an S path, and for their nesting domain or domain which tunnels from SRMPLS, it's absolutely ePath, so the end-to-end path identifier is transparent. So it's only ingress and egress are dealing with it. So this is a start of this work. There are a lot of be worked on, and there will be new updates. We appreciate comments and your interest and working together. I hope I saved some time.
Rakesh, so I think this is already in the spring draft, right? It talks about path segment for stitching the multiple domains and stuff.
Can you send the reference to this draft? Because
it's a draft that you had referenced.
Well, again, in my understanding of this draft, it does not go into the detailed specifics. It goes that it's possible. So
yeah, it covers the use case that it can be used to do this.
Okay, let's take it offline.
Dhruv, Huawei. One question, why are you using path segment for stitching instead of using binding segment?
Okay, that's a good question. I'll have to think about it. But thank you for the question.
Yeah, I think the Rakesh again. So path segment is the traffic that's coming in, and binding seed is the traffic that's going to leave. So you need to stitch the binding path segment with binding seed.
But
Okay.
both of them are used to Tariq from Juniper. So the path segment is going to stitch from domain 1 to domain 2, right?
Well, the path segment, basically there needs to be a correlation from one path segment. Again, it's in a stitching model. There needs to be correlation between path segment in one segment to the path segment in a downstream segment.
So it's going to be maintained all the way to the end?
By the boundary nodes, yes. Only by the boundary nodes.
So, Lo Anderson, I'm going to talk about a set of registers, actually a subset of the registry under the heading LSP ping trace route register in the IANA. And it's basically all the TLV and sub-TLV registers plus the message type and return codes and one more. I have had, as long as I've been chair, I have had a problem here by understanding the rationale behind how it was done. So let me try to explain. So they have a background. It started out at 4379. 4379 defined the structure. 8029 updated 4379 and changed some of the registers, but not all. And all the changes that was in 8029 did not get into the actually IANA register. So there is a discrepancy between what the current RFC says and what actually in the registers. 80 time to wake up. I'm in some other continent somewhere. The 8126 is more or less contemporary with the 8029, but it's rather different. There are subtle differences that actually affect the registers. And when we did the last working group RC 8166, we actually took what is in 8029 and actually put that into the registry to get a model to work from. There are two groups of registry. I've taken the simpler one to actually show my points. 4379, it's a very technical, solid document, and it says for the IANA registers that it needs to values from the specification required procedure needs to be done by an experimental ROC. This is kind of an oxymoron. It's not wrong, but it's kind of complicating things more than necessary. So this is what it looks like. Okay, so updating things to, uploading things to the IETF actually got rid of my my buildings. So if you look at a registry, for example, message type, there is one part is a standard action, no problem at all, it works just fine. There is another one that says specification required and says that it's only experimental ROCs. So a specification required is almost any document with any stretch of your mind can call a specification. And it actually brings in the requirement for designated experts to support IANA, to allocate them. If we look at the experimental ROCs, but there are only 4 types of documents. It's IRTF, IAB, IESG, and independent. No other document. So why use something that says we can take documents from the entire world to actually describe what we're doing in 4 types of IETF documents? So 8029 changes the experimental ROC in 4379 to ROC, but basically this did never get into the IANA registry, but basically it has the same problem. We have a lot of we can do any IETF ROC, but it's the same problem. It's much fewer documents, but then one actually indicated in the specification required. Sorry about the animations. So we have one more thing here, saying specification requirement, RC needed in note, is actually saying the same thing as using the registration policy RC required. Stuart, give it to Coretti, he came late. So we can, without any problem, change this to a RC required, saying the same thing as 8029 says. Here are the list of possible registration procedures. And I actually come to the conclusion we should use them. We should not try to invent our own. So I propose going from specification required to RC required. An alternative would be to go to IETF review. That would actually exclude quite a number of documents, but I don't think it's necessary. So the update we have made is actually align the concept with 8126. We added code point for experimental use. Actually, I've heard from people that actually were part of co-authoring 4379 that when you use the experimental ROC needed, you allocate a experimental code point. But that's not true. It's a general code point that anyone can use. It's specified by an experimental ROC. And then we are listing all the registration procedures, even if they don't result in any allocations, even if they prohibit allocations. So this is what the registry would look like with what I've been talking about. So we have the standards actions, we have the ROC required, we have experimental use, and we have private use. The last one is probably vendor private use. I don't remember, but yeah, I think that's all. No, okay, yeah. We request for a working group to review this and actually comment on it.
I think you should just last call it now. I'm kidding.
You can do a working group adoption poll if you want, but you can't do a last call.
Fortunately, I didn't say my name, so it's okay. So, Kiriti Kompella, I was probably on something when I put experimental RFC required. You're completely right that it should be RFC, instead of specification required, it should be an RFC, which is what I wanted. I don't know why I said experimental. So RFC required is, I think, the right thing. And then the others are as is, right? I mean, they haven't changed. I think for the private use, usually back in the day when I was actually thinking about these things, I would say that you need a vendor code point before you actually put the, but yeah. But here, I don't know if there's space for that. But no, go to the, where you have the final listing of the, I think it's, yeah, the one before this one. So I think this is what you should be doing, so.
Thank you. So we should also say that Kiriti was actually one of the co-authors of, one of the leading authors of the 4379, so.
Yeah. For offer consideration, in some allocations, and it's been kind of popular to make 0 and 255 as a reserved value, so not to use them.
But now we're talking about something else. Those are the registration procedures.
Right.
When we list the assignments, then we list 0 as reserved. So that's another part of the table. Any further questions? Okay, thank you.
So I can start introduction. My name is Zafar Ali. I'm going to present the draft on behalf of my co-authors. Basically, the draft is asking a question for us. We have in SR various segments, and every time we define a new segment type, we have to come back to O&M and define a new fact type for validating that segment type. Next. Oh, I have that. So this is, it doesn't stop here, but it actually requires software upgrade for the nodes that are deployed in the network. And rather than O&M being working in lockstep with any forwarding definition that is deployed, it starts to lag behind. Like EPE, for example, is deployed, but there's no facts, there's no O&M, and it causes a lot of problem. And when a new fact type is defined and it requires the software upgrade, it also had implication on the usability from the user point of view, and I'll explore a bit more. I had that question when Shraddha was presenting the draft, and it's some scalability challenges. So this is some of the facts that are in the discussion. And the main point here is just sheer amount of information that is required by the user or by the system to input in order for us to do a ping to a remote SID, to have that thing set up. And it's a lot of information. And same thing is that, I mean, let's say we define prefix SID for prefix SID, but it doesn't work for flex algo. So it makes us think one step back and then say that, can we simplify this? What is that we are trying to achieve? What is the data model for an SR data plane? And can we make it consistent, the fact definition consistent with the data model of the SR data plane, so that it works once for all the fact that exists today and that come in future? So that's the problem statement. To simplify the process, the segment routing is all about simplification of network operation, and we have a problem here. We cannot hide that problem. The other thing is also that if you look at the slide, yeah, unfortunately I cannot move, that when you have peer node SID, you do not know the target ahead of time, because let's say if you go between the node 2 and then 4 and node 3 are peer SID, peer node SID, so they share the SID. The decision whether the message will end up with node number 4 or node number 3 depends on load balancing and node 2. And node number 1, who's the node asking for ping, does not know that decision. So it cannot fill in the information about the egress was supposed to receive the packet. All it knows where this SID is. SID is advertised by node 2. The SID value is X, but I don't know how node 2 is going to load balance that SID and where my target is going to end up for this ping. It all depends on node 2 behavior, not what I can control. Same thing, when I have a parallel agency between node 2 and node 3, at node 1, when I'm pinging agency SID, I don't know which link would be selected. So I cannot select that. And we have, in RFC, we have method that, okay, for parallel agency, just put 0. So, I mean, we have hacks to get around it, but we don't have a solution. In the other draft that Shraddha presented, we said, let's send all the possible. There could be many, and then hope one of them would be there. It increased complexity, and it makes O&M really lag behind. So solution is really look at the SR data plane. The SR data plane is simple. You have a segment ID, and that segment ID is advertised by somebody. This is the common denominator. It doesn't depend on the SID type, what SID type is and all. It does not depend on. So step back and then simplify the facts definition that works for all SID type now, and that may come in future as well. Since this is based on the data model, it will work for sure. Now, here's the definition of the SID. Again, the SR SID and the SID assigner. For some simplification, for some use cases like binding SID, we also include optional LSP endpoint, which is if I know who should be responding, I can put it, that information. But I'm not going to go this busy slide, but there is an exercise that is done whether this definition works for all SID types that we have defined or we have to define in future, or it doesn't work. The answer is yes. I mean, you can review it. I can come back to it if there are more time remaining, but I'll go and illustrate a few examples first. So in this example, we have prefix SID. Now, here is the prefix SID, which is for flex algo 0 and flex algo 128. Current definition of prefix SID does not work for any algo other than flex algo 0. And there was an attempt to modify the fact, but it goes through the same problem. So how it would be done is basically node 1 will just simply say, I want to ping a label which is advertised by node R8. This is the only information that is carried. Now, we pick here agency SID because agency SID is difficult. It is for prefix SID. So when it comes to node 8 will say, yes, I am the assigner for this SID. And yes, this label match my table. And then response goes back to the originator. Now, we take this example and try to address the parallel agency, which is not addressed by the RFC today. The parallel agency case cannot be verified if in today because it says the agency is 00. So here we have 9778, which is a parallel agency between link 1 and link 2 between node 7 and node 8. In this example, the fact would be chosen. Again, this is agency that is advertised by node 7, okay? And this agency value is 9378. So this is what is the bare minimum information that is required. When the packet goes to node 8, and it can optionally contain the endpoint, but endpoint is not mandatory. But when the packet comes to node 8 can then verify that this is not a local, this is advertised by 7. So it says if 7 is my upstream neighbor, and it verifies that it is matching on the interface I received this packet on with the parallel agency that is advertised by that node. So in this case, 9378. So it can easily verify from this local table that information. So it works for parallel agency. It will work for the EPE cases as well and all. Now, this is pair node SID. It works the same way because the common denominator is node 7 is advertising an agency which is 9378. Now, packet comes to node 7 and it can either go to node 8 or 88. Either way, the receiver will say that the advertiser is not me. It is, let me check if it's my upstream label. Does it allocated this agency? Did I receive packet on the right interface or not? And then it will respond. So it doesn't matter how 7 is doing its load balancing. The packet may end up at node 8 and it will respond if the right interface is chosen. The packet may end up at node 88 and it will respond if its right interface is chosen. And if it end up with a wrong interface or wrong neighbor, then the response will be negative as well. So all the validation would be done and it works. So in a nutshell, we are trying to simplify the segment routing FAQ by defining FAQ, which goes back to the common denominator of the data model in segment routing. It's done for the ease of operation because then user don't have to input all different parameters needed. And we saw the complexity of all the FAQ. And it is defined such a way that, it would be consistent with any future segments that would be defined. And for INR history, I will skip this. This was a question, Lua, from you on the mailing list. It's consistent with whatever you decide, but it's really a new fact type of the TLV 116 or 21. We already discussed this MPLS Spring Working Group in the other discussion that we will discuss also in MPLS and Spring, but the fact definition in more specifically Spring, but we'll let chair decide how they would like to proceed. With that, I would like to ask for feedback. There is some discussion that going on with Shraddha. We tried to connect in past couple of weeks, but was not able to, and then we have meeting tomorrow that we will discuss more on this.
Mukul from Juniper Networks. One observation is here, as a matter of simplifying things, I think we are trying to pack a lot of information in one thing, which I do not agree, and I will tell you the example. So, for example, can you go back to the slide where you have node 1, 2, and 3? So,
This one?
no, the previous one, the very beginning.
Yeah.
No, go back. At the very beginning, when you had parallel seeds and all. Yeah, this one. So you claimed that node 1 will not know which interface corresponds. So I'm talking more, let's say, BGP egress adjacency seeds. So today in BGP adjacency seed, when it is advertised in the BGPLS update, we along with the label, we also advertise the IF index of the router 2 from where the packet will go out. And there is also already a field which tells out what is the IF index on which node 3 will receive the packet. So that way node 1 knows via controller or something, it can know, given a label, what is the IF index from which the packet will go out from 2 and what interface 3 will receive. And there is already other drafts which are there to add all the information which are presented regarding given a node, all the, like if you talk about the set seed, what are the interfaces, local node as well as remote node, which will be known to the node 1.
Can I answer that?
Yeah.
What I said is that node 1 does not know how node 2 would load balance any given ping packet based on the hashing that it's putting in the ping packet, whether it will land on node 4 or node 3. It would not know. Okay. Right. So the only way to do is to pack the entire list of possible pair node in FAC. Correct. And this is bringing complexity for both ingress and egress. How you expect the operator to input this data? I mean, it's just going out of proportion. I mean, it's too complex for user to use it. We're looking for simplicity. We are asking not more complexity. I mean, think of it. I mean, ICMP, you don't need any of this. I mean, people are operating IPv6 network for ages, and you don't get into these issues.
Okay. The other comment I had was regarding what was that comment? You can go.
Greg Mirsky, ZTE, and I would like to use this example that what you mentioned, ECMP. Yes, ECMP is challenging, but I don't see how you can guarantee that with your method you will explore all possible downstream from 2 paths.
It's simple, because when the message is received by a receive node, let's say if I'm node 4, right, I'm going to check who's the advertiser of this SID. It's not me. Okay, that means it's an agency SID of type. Okay, is the guy who is advertising is my upstream neighbor? Yes. What is the value? Did he advertise this value for this SID on the interface I received the packet on? And that's all I have to verify.
Okay,
it will work regardless.
My question is different. How you explore all paths from 2? So how you can reach from 2 to 4 and explore all 3 links from 2 to 3, because that's what's important. And in LSP ping, if you look at DS map, so 2 will be your responder and 2 will be list you what is downstream, and then you can use this information to reach explicitly of each possible path. So I think that, yes, there might be some value on doing downstream responding on behalf of advertising, but it must be complemented by advertiser responding and verifying the fact itself.
Yeah, but when 2 respond, it exactly know how it's going to load balance. So 2 knows the information. So we are not talking that it will land to a wrong guy, right, and so, we cannot do.
But you need to explain in your proposal is how you guarantee that their head end, the one, can control the information in the packet that you construct, so it reaches all possible edges.
That's an orthogonal problem. That's not the problem we're trying to solve. That's the problem by exploring the tree, okay? And then you can change the load balancing parameter, and you can achieve this. But the point, your problem, the point is that when two respond back to the with the DS map, DD map, it can include the exact interface information because it knows how it's going to do the load balancing.
Yes, my name is Shraddha. So the comment that I have is the problem that you talked about in the beginning of your slides, that we have these EPE SIDs implemented, but we don't have OEM FECs implemented for those. That's a real problem, but there is different way for solving it, right? So when we define a new SID, we also define the FEC for it. We make it mandatory, right? So that's another way of solving that problem. So all those upgrade problems and other things you talked about that wouldn't exist if we had done it this way. But we didn't do it that way, and we are in this situation now. At least going forward, we can make sure, any new SID that comes along with the OEM FEC for that.
It's not only OEM FEC, but it's also the information that is needed this OEM FEC.
Yes, of course. No,
think about this information, and there are operators sitting here. They can say that, okay, it's like human, how it's going to enter this. I mean, I look at command line and out of my OR characters limit.
Of course, if you expect the operator to enter all this information for ping and trace route, not possible. But that's not necessary, This information has been advertised in the network, and there's one guy who knows this information, one node in the network who has all this information, and that should be capable of preparing the FEC, which is totally implementation, right?
But to achieve what? To achieve what? So you can verify control plane, and you get data from the control plane to verify the control plane. So what do we achieve by putting all this complexity in the system? We did not achieve anything.
Right? Two parts, right? There is control plane verification and control to forwarding plane synchronization verification. And with this, with what you're proposing, you're completely taking away the control plane verification.
Yeah, but
it's
control plane,
plane
you cannot get it unless you get the information from the user and from a source which is not control plane. You cannot verify something by getting information from the very source that you're trying to verify. Okay.
So that's always been how it is, right? So if you see MPLS ping and trace route, the RSPP or LDP, the head end prepares the FEC and it sends it. And head end, how does it learn it? It's a control plane learning, right? So that's what we're trying to propose.
The head end knows I am pinging this tunnel, and it knows what is the FEC of that tunnel. It doesn't ask a PCE or some other control entity. It is the one that has installed that tunnel. It is the one that installed the tunnel ID. It is the one that selected entire FEC.
In SR, we're talking about a controller setting up the tunnel. So whoever sets up the tunnel, right, will have that information. In case of RSVP, it was the head end. In case of SR, it's the controller. So whoever sets up the tunnel should have all the information.
Yeah, but whatever information that has learned through BGPLS and is a control plane entity, you take that as a master.
Synchronized control plane sync becomes even more important in this case because it's gone through so many things.
But
right?
you get it from control plane that you're trying to verify it. I mean, that's and the complexity here as well.
One more comment. I think we can take this offline. One more comment I have is regarding there is a nil something called as nil FEC in RFC 8029, which is pretty much doing the same thing what you're proposing, a little different maybe.
Yeah, but there is no validation in nil FEC. This brings validation.
Yeah, at least there is there can be a forwarding plane validation. You could send a DDMT and then you verify the DDMT in your next router.
Yeah, but when
I
you
feel that this already exists, some kind of a generic, if you want to use some generic OEM validation, I feel that already exists in 8029. Maybe we can take it offline.
We can take it offline, but I mean, there is no validation that nil FEC does. It is there in the RFC.
When you say take it offline, yeah, okay, go away and discuss it, but make sure that you actually get back to the list.
Sure. Yes.
Rest of us need to know also.
Sure.
Mukul from Juniper Networks. One comment for BGP EP SIDs. Those SIDs are special in the way that if you talk about 3 routers, 1, 2, and 3, those labels are allocated at node 2, for node 3. and node 3 has no knowledge about that label. Okay, so the flow chart which you have, right, that will fail.
No, it would not.
Can you go up?
We can take it offline.
Yeah, we
but
can take that offline. But the
Yeah.
main point which I'm trying to bring it up is the EP nodes is label is allocated at node 2, and the LSP ends right at node 2. So node 3 has no knowledge of that label. So when you do a ping from the head end, that LSP has to terminate at 2.
If it's a prefix SID, yes, it would
Not
terminate at
prefix
2.
SID. I'm talking
Yes.
about the BGP EP SIDs,
Yeah.
right? So it will end. EP SIDs are a little bit different, and here the validation has to be done for the outgoing interface, not the incoming interface. Most of things what you have talked about label corresponding to the incoming interface, but EP SIDs are a little bit different.
We can take it offline, but it works.
Yeah.
Zafar, before we close, Tariq from Juniper, I did review your draft, gave you comments on the list.
Yeah.
In general, I'm okay with generalizing the effect, but not dropping information that this allow us to do control plane with data plane validation. So I'm okay with abstraction, but with abstraction, you lose data that you need to validate. So if you can find a sweet spot in the middle where you have the information and you're generalizing, I'm okay. But there's a couple of other comments also that I gave on the list. Maybe you can respond.
Yes, I'm behind my email, so I apologize. But regarding that comment, look, if my main thing is that this is too much information for any user to give, if you use control plane, we're fooling ourselves. So why bring that complexity? Okay, that's my comment. We can take it offline.
But that's that argument in the draft. You are saying I need to rely on a controller to tell me the information that is the packet coming on the right interface. So it is complex. Your approach is complex.
No, if I have an IGP, I have local database that I see this guy advertised this said yes. If I receive on the right interface, yes, and it works.
But the same argument applies. Either way.
Yeah. Anyway, yeah. So let's take it offline. But I disagree with it. I think it works, and it be in benefit of the industry. It would bring simplification. We would not have to keep chasing this fact after fact after fact. It is a problem. Thank you.
Thank you.
I just want to say something about the discussion. I prefer that we actually let people talk to point before they actually respond and not interrupting. I'm talking actually about both Zafar and Shadra, they're doing the same thing. This time it was useful, but think about it in the future. We let people talk, let people make their point before you try to correct them. It's me. So Tariq has done us a service. He actually introduced a font that actually disappears when we put it up on the IETF. So if I remember correctly, it said the synonymous flow label drafts, and it's gone. No, go back. I'm not going to use that slide. We have 3 different drafts that the main author, Stuart, told me are stuck, and I tried to figure out how, and I tried to write down what was the problem, and Stuart says, you got it almost right. So I kind of stepping back and let Stuart try to explain what the issue is and where we should go from here. I would prefer if we get a simple solution.
Right, let me explain where this is. The framework draft, that's in pretty good shape. I need to read it through again, but it doesn't need much work. It could go through to last call. The solution draft, pretty good shape. I need to read it through. It could go to last call, except for one thing. By the way, they do. I forgot to refresh them. I'll refresh them when I get back to my office at home next week, and I can got the sources again. So there is one field in here which is a tag field. which was requested by a group of implementers in order to simplify the internals of their operating system. That is called up by the control draft. Now, several corporate lives ago, I stood at the front of one of these meetings and introduced this control draft, which is a very simple scheme that largely George and I put together, a lot of work from George. And it doesn't require us to touch any of the other control planes. So when I stood up here, people said, no, Stuart, we need an RSV PTE solution. We need an LDP solution. Presumably we now need a solution for the IGPs. And I have not had time or the funding or anything to do this. And I've been requesting other people help me here. So we can do one of two things. One of three things, I suppose. We could mark the tag field in here as reserved and take a risk that we got the size right. Or we could go forward with the control plane that I originally proposed. And if people want another control plane, eventually they can write it. Or we can continue to stall the whole project until someone with enough time and bandwidth to write the control plane document that describes all of the MPLS control planes, until they come forward and they write it. But it's stalled because this relies on this. The working group said we want something much more complicated, and I haven't got the time to write it.
Stuart Tarek from Juniper. So if we had a controller, would that replace the one in the middle as not needed? The one doing allocations for these synonymous.
Right. So this this design here actually has a lot of merit, right? Because it doesn't require you to touch the real control planes. It sits underneath the real control planes, and just if the OEM system says it wants to do this operation, then a label is sort of silently inserted to replace it. So that actually has a lot of merit as a system. And people I don't think, we'd have to go look at the minutes, people didn't object to that. They just said we want a lot more. We want RSVP and we want LDP and etc. And if someone wants to write them, I would be happy.
So I've been, Lou Anderson, I've been struggling with this for some time. And what I'm trying to understand is there a way of going forward with something very similar to what you have here, a simple solution, but actually putting the hooks in to actually allow anyone that wants to do very much more than you want to do that? And how does that look?
So remember, there's one thing. The tag field that I put in is in the data plane. It's transmitted with every packet. And so I'm always very nervous about doing anything in the data plane unless it's perfect, because it's very expensive to change. Adrian, say something.
It's Adrian Farrell. I have two questions, but I reserve the right for a third question. The first question is just to check that I'm not misreading something. All three of these drafts are currently expired, yes?
Yes, my mistake. Okay. I will refresh them.
No, that's fine. That's just what I wondered why I couldn't find them. Second question is, to the specific point of the control plane, why don't we just document what people have implemented?
I'm not sure whether anyone's actually implemented it either.
Right, and then I will exercise my right to the third question. Why are we debating last calling documents that people haven't implemented?
Because people tell me they want an RFC, but I'm fine with whatever we decide to do.
So that left us with another question. Then actually, we have been taking these two documents through the working group, and people say, working group says they want to progress them. So that's why I'm pushing for a solution to actually make them RFCs. If there are suggestions that, well, this is not implemented, it will never be implemented, so why should we bother? If that's
But I do hear people who say, I would like to have the RFC and I would like to build it.
yeah, that's what I hear also.
Sorry, Ryan Hoffman from TELUS. I haven't been following your work, but it would seem an applicable action to this would be a mirroring SID, that on a hop-by-hop way I give a secondary action to produce a copy of that frame for diagnostic purposes.
That's kind of what it does.
Yeah, I would think operators would be quite interested in such a capability.
So I am fine. This is all a package of work. We wanted it when I worked several employees ago. Several people have said they want it. It's just stalled on people saying that they want a more sophisticated control plane and finding someone to write it.
I misunderstood you. Okay, sorry.
So anyone that is smarter than I am, anyone have an idea what we should do? My take is that we should actually go with the simple solution we have, but make sure that it has the possibility to be extended if you want to.
All right, I'll take a look at the bits that are embedded in the control plane and make sure that in the data plane and make sure that they're either probably adequate or we can change them if we need to without mass destruction. George, you going to say something about this?
Yes. I haven't looked at the draft in several years.
Indeed.
I am retired, nominally anyway. Do we have a requesting process ID in the initial exchange? Because if we did, then, you know, somebody who wants it to be requested through RSVP or LDP or BGP could build an invitation that says, okay, RSVP is going to request this thing, and then the request comes back to RSVP. It's just a suggestion.
Yeah.
Popped in my head.
Maybe I should talk to you offline and take you out of retirement for a few minutes. Okay?
Yeah, okay, thank you.
Just tell me what you want me to do there.
I think I did.
Which was? For the minutes?
I think she said, I want to have the simple solution that was sketched there.
Yes.
That I want it to be possible to extend in the future. There is someone actually shows up and wants to do 62 different control planes.
Good. Okay, that sounds like it would work for me.
So this is the end of the MPLS working group meeting in Montreal. Next time is Singapore.
Just that last one.
Couple of months out. So have a good week here. Safe trip home. Safe trip to Singapore, and see you all there. Thank you. We have one blue sheet. We have one more. Where is that? Where is the second? No one leaves the room. We need a second blue sheet.
Yeah, go ahead. Look all you want to.
At the same time.
What?
Same time. That's a
Yeah, no, so it was, but it is projected.
Huh?
It is projected. You could just only see the shadow of the text.
My second surprise is the animation that
Yeah, so it now automatically converts to PDF.
I want an agreement signed by the IEC and the MPLS on if I have to do or two parts for the signed by